Okay, so the negative exponent means reciprocal. So this means reciprocal. It does not mean negative number. So make sure you remember, don't move this minus sign in front of 2. Okay, so we are going, usually we do 2 steps. So you can, this 4 means 4 copies of the base, but this minus in front of 4 means actually reciprocal. So we can do 4 copies of 2, which gives us, multiply 4 copies of 2, that gives us 16. And then we do reciprocal of that, which gives us 1 over 16. And similarly, 2 to negative 3 means 3 copies of 2, which is 8. And this minus tells us to flip 8 to get 1 over 8. Okay, so first of all, you simplify, you found the exponents of each one. And then we're going to add the 2 fractions by finding the least common denominator 16 and equaling the denominator. So we should get 1 plus 2, which is 3/16. So that's the correct answer for number 2. The first one, I think one student made a minor mistake, everybody else got it right. So we are going to multiply both sides by the least common denominator, which is n. So we multiply by n and n and n. And notice that the factor n cancels the factor n, and the same here. So we end up with a very simple equation. All of these are canceled out. We're left with the top 4 minus n plus 2 equals 7, because they are canceled out. So all we have to do is combine like terms. Notice these two combine to get positive n, not negative n. So you have 4 plus n equals 7, which gives us 3 for n. Subtract 4 from both sides. Okay, and again, quickly plug it into the equation to check whether this is the correct answer, or the most important thing is make sure that after the you plug the number back in there, you're not going to get 0. Suppose after I solve this integral equation, the equation with the whole numbers, integers, I end up with 0. And you plug a 0 into the bottom, it's going to be undefined. Then you will have to say the original fractional equation has no solution, because it could happen. I think, I'm not sure. I think the homework problem probably didn't give you anything like that, but you need to remember, keep that in mind. It possibly could happen when you found a solution for the simplified version without fractions, and you found a answer say 0, but when you plug into original, you find out it's undefined, and then you just have to say the original equation has no solution. All right. Okay, so this is the bonus question we talked about last time, and now we continue to go back to review the problems we discussed. So the main thing is the definition of negative exponents in section 5.1. So negative exponent, remember, it means flip. So I give you one right here, one example here. So let's go over this one more time. All right, when you're given a specific number, you would know like 2 to negative 3. So you can do 2 steps. First, you do 2 to the third. That gives you 8. And that negative exponent tells you to flip to get 1 over 8. The other possible way you could do is you can flip negative exponent. When you see negative exponent, you could flip that number 2 to get 1/2. And then you deal with that 3, the third exponent 3, and to do 3 copies of 1/3. And that gives you still 1/8, same answer. But if you have a variable, a to negative 3, so usually we follow the first solution this way. So we're going to take 3 copies of a, which gives us 1/3, and that minus sign means you flip it. So that gives you 1, I'm sorry, not equal. You get 1 over 1/3. The other way also works. So if you say, okay, I'm going to flip a first, you're going to get a 1 over a, because this minus in exponent tells us to flip. So I flip a, I got, because a means a over 1. So when you flip a over 1, you're going to get a 1 over a. And I'm going to do that 3 copies. So when I do 3 copies of 1 over a, I can use the formula we learned to do raise 1 to the third, raise a to the third. And we know 1 to the third is 1. So you end up with the same answer. But the first solution will be a little easier. So this is something you kind of have to memorize when you're asked to to do a to negative third, you're going to get 1 over a third. And how do you remember that? And you can use the first, sort of the first definition. Okay, so first you kind of ignore the negative exponent. Ignore the minus sign. Just do to a to the third. After you get the answer, whatever that is, just flip it. So a to, in general, a to negative n equals, so I'm going to do n copies of a, so I get a to the nth. But there's a minus, which tells me to flip. Okay, so the relationship between a to negative n and a to n, they are inverse of each other, which means reciprocal of each other. You flip. You flip one of them, you get the other. Okay, so this is equal to 1 over a to the n. So that's something the definition. So now we're going to continue to look at more examples. Okay, so before, so we think here, I'm going to give you some practice problems to review these, let's see, 5 formulas right here. Okay, so these 5 formulas, we used them in our first exam. If you're still not quite familiar with these formulas, or you forgot these formulas, I did notice in the grading of the first exam, some students still had trouble with these formulas. They forgot when to add exponents, when to multiply exponents, and that's the main mistake. All right, so now I'm going to give you some quick practice questions here. Okay, so I will give you a link, and you will write down. I will give you a link, post a link like we did before, and you can tell. Let's see, and type the answer in. Okay, so that's the. Okay, the other ones are sort of like, I'm actually just gonna do this because the other ones are fractions. It's not, I can't really type fractions. I'm gonna write down the questions on PowerPoint slide, and all you have to do is type the answer in there. Okay, Q4. I'm just gonna put question 1, question 2, and question 4. So you can go to the chat box and click on that link. It's still sending. Okay, so click on that link. The first one, I typed the question there, but the other ones, I'm gonna write them down on the PowerPoint. So the second one, I had the first one there, but the second one, third one, fourth, 2, 3, 4. Okay, the second one, I'm gonna put it right here. Y squared x third. The second one, the third one. Oh, I have an extra B there. I'm sorry. In the first question, there shouldn't be a. Oh, there should be a C. Sorry, there should be a C. Okay, sorry if you. There was a C right there. Aiden, you also need to submit the type your answer for the other 3 questions. I didn't type the question there. I put the questions on the PowerPoint, so you gotta look at the other 3 because we have those.
Yeah, I did the other 3.
You did? Wait, I don't. Oh, okay. I'm sorry. I also only look at. Okay, I see it now. Thank you. Sorry. Okay. Good. Okay. Good. Okay, very good. Actually, Aiden, you got all of them right. That's good. And Ellie, you also got all the questions right. Oh, wait a second. Ellie, you missed the last one, number 4, the number, double check on that number, 5. Because 5 is inside the parentheses, so that should also be squared there.
Where do we submit these at?
You click on that link in the chat box. Do you see can you see a link in the chat box?
Yes, I clicked on it.
Okay.
It won't pull up on my laptop. It just says it can't be opened.
In that case, you just type your answer in the chat box. Can you? And Jackson, Natalie, you also got these. Oh, Natalie, I think you made a mistake in the last one, number 4. Double check on the exponents. The others are all correct. And Jackson, you got all of them right. Okay. Ryan, do you have a question? Okay, any more submissions? Well, if you can't access that link, just type your answer in the chat box. All right. Okay, well, so looks like most students who responded, I got 8 responses. That's most students who responded.
I'm typing mine right now.
Okay. All right, the first problem, let me see. Abby and Garrett. Okay, you guys made a mistake in the exponents. In the first question, I think, Abby, you're adding the exponents. But in this case, you're supposed to multiply the exponents. I'll explain in detail in a second.
Okay, that's what I was confused about. Do you want me to try again, or?
Sure. Yeah, go ahead. You can submit again, I believe. I'll just see 2 submissions of you. And Bryson, you also added the exponents. That's not correct. So you're supposed to multiply the exponents. Okay. Garrett, I actually not sure what you did. I don't know how. Oh, wait. I'm not sure. Yeah, I think the first part, the first exponent was wrong, but the other 2 seem to be right. Okay, the second one, yeah, and also the same mistake, Abby and Bryson. You're supposed to multiply the exponents. The third one, everybody got that right. Okay, and the last one, okay, so also I guess the same problem with the exponents. Stephanie, you got all of them right. Okay. Okay, so now let me go over these questions here. The first one, so here we have a couple of students who were confused about when to multiply exponents, when to add exponents. So I'm going to show you here one more time here. Okay, so the tip I gave in class was if these 2 exponents, we can call them power, these 2 powers are right beside each other, you are going to multiply them. But you may say, well, right here, they're not beside each other. Why should we multiply them? Well, because we actually skipped a step. We're supposed to use the third formula. Yes, the third formula. When you have multiplication in the exponent, in the base, look at the third formula here. If we have multiplication in the base, x times y, okay, like x times y, you need to, by the definition of parentheses, what do the parentheses indicate? It indicates that you will raise each of them to the exponent, because this n means n copies. You got to do n copies of both x and n copies of y. Everything inside parentheses needs to have n copies. So that's why we raise x to the nth and y to the nth. Okay, and so look at this question. This step can be omitted. A lot of students just got the answer right. So, but technically you're supposed to use that third formula to raise a squared to the third, and then raise b fourth to the third, and then raise c to the third. Now look, the exponents are there beside each other now. Okay. The only time you will add exponents is when the exponents are, for example, a squared times a third. See, this third is the exponent of a. It's not an exponent of a squared. Although they're not beside each other, when you look at this, what does this mean? It means you have 3 copies of what? 3 copies of a squared. You don't have 3 copies of a. So the difference is right here. So you have a squared and third, because everything in the parentheses need to be raised to the third. So you will get a squared and third. Again, this step can be omitted, but if you get confused like, oh, well, should I add or multiply, then you shouldn't skip this step and go ahead and write down that step. That will tell you, okay, 2 and 3 right beside each other. I should multiply them. 2 times 3 is 6. The same thing here, B and 4, 3 and 4, they're beside each other, so we multiply them to get 12, and then C third. Garrett, I think what you did, you got 8A, so you probably did a 2 to the third. You raise the 2 to the third, but actually you don't raise this to that. It just means you multiply them. Okay, so it's like 2 times 3, not 2 to the third. All right, so that's the answer to the first one. So make sure, Abby, do you understand this now?
Yes.
Okay, all right, good. Because in the second exam, in the final, we will still have these questions. So you will still need to know when to add and multiply. Okay, now next, let's look at the second one. The same thing. I mean, you may skip this step, but in the formula that we said, if you have, okay, let me find the formula. So if we have, besides multiplication, if you have division in the base, you can still raise each top and the bottom to that exponent. So right here, we will raise the top y squared to squared. So it's like squared, and x third squared. And you will get y, 2 exponents beside each other, you multiply them, power of power, and you multiply 2 and 3. So that would be the answer of the second. Now the third one, it's division. So we split it into 2 questions. Okay, and x fifth divided by x fourth, then you're going to get 5 minus 4. That gives you x to the first. So you do subtraction of exponents, and y 4 minus 3 gives y to the first. Now the last one is the most complicated one. We did have something, so all these questions, we did similar questions in the first exam. And we will have similar ones again in the second exam. If you looked at the practice exam, we had the similar questions, but with negative exponents. So I will, if you know how to do these with the negative exponents, you should be able to still be able to do it. You just have to be careful with the negative numbers. So first we start with the inside. Negative 25 divided by negative 5, that gives us positive 5. A third divided by a, so we're going to subtract the exponents. We get a squared, because a means a first. B fourth minus divided by b squared, we subtract exponents, we still get b squared. Okay, so we have, then we can use that formula. So don't forget, a couple of students forgot to raise 5 to the second power. So remember, if you have parentheses, everything inside the parentheses needs to be raised to the exponent outside. Unless I move 5, if I give you a question like this, see, this 5 is not inside parentheses. You don't have to raise 5 to this exponent, has nothing to do with the 5. But if it's inside parentheses, that means this 5, you need to raise 5 to the second. So you will have 5 to the second, a squared to the second, and b squared to the second. And 5 to the second will be 25, and a squared. You multiply the exponents, so you get that. Okay. All right, so these are the answers of these 4 questions. Next, I'm going to make some changes because we're talking about negative exponents. So now what if I change some of them to negatives? Okay, so exactly the same questions, but I'm going to pick some of them. For example, I'm going to make this one negative 2. Oh, I had a b fourth there, sorry, b fourth. And oops. Fourth. Okay, so I can change this to just change this one. Okay, the others I can keep them. So when you do the question, nothing's gonna change. The way you do it is not gonna change. Okay, so you will still raise each one to the third, but notice that we have a negative 2 here. So I'm gonna put a negative 2 here. So you raise a to negative 2 to the third, and b4 to the third, c to the third. The others don't change. The only difference is right here, right? So when we multiply negative 2 times 3, you're going to get negative 6 instead of positive 6. That's it. So as you can see, the way you do these questions is going to be exactly the same. You just have to deal with negative numbers. You can stop here. You can leave your answer like this. But if you want to get rid of negative exponent, let's quickly go over that. So the positive exponents, positive 12, positive 3, they stay. I can put 1 underneath to indicate they are on the top. So P12, C3, they will stay on the top because if you don't have negative exponent, you cannot flip them. The only time you can flip something is when you have a negative exponent. So A2 negative 6, this negative sign tells you to flip. You get 1 over A2 6, which means A2 6 is on the bottom, right? So when I did go over that right here, take a quick look. See, whenever you have A2 negative n, you will have to flip in order to get rid of that negative exponent. To get a positive a to the n, you will have to flip to the bottom. So originally it was on the top. See, when the answer you get 1 over a to the n, you flips it to the bottom. Okay, so that's the idea I'm applying here. If you want to simplify this further, you will get that. But like I said, I can accept this answer. If you don't want to flip, you can stop right there. Okay, now the second question, we are going to do a similar change. I'm going to change one of them to negative, very similar to the homework. So I'm going to make this one a negative. The top one, I keep it as positive. So when you do the question, you're going to follow exactly the same steps. Okay, like I said, you can skip this step if you want. You can also skip this step. You just have to do it in your mind. So you will do 2 times 2. So you still raise the top to that exponent. 2 times 2 is still 4. The bottom, negative 3 times 2. So we have a minus sign here now. So you get a negative 3 times 2 gives you negative 6. But don't leave your answer in this form. In previously, number 1, I did say you can leave your answer this form if you don't want to flip. Okay, so this is acceptable. But this answer is not acceptable. Why not? Because you are mixing 2 forms. So there are only 2 forms are accepted, which 2? You can either have only exponents, no fractions, or you can have fractions but no exponents. You cannot have a mix. Previously, when I get the answer A2 negative 6, B12, and C3, I don't have any fractions in here, right? I put over 1 to help you to visualize how to flip when I do the flipping. Oops, I can't erase that. But you don't really have any fractions in this answer. See, no fractions. Or you can get rid of negative to put in as a fraction. Okay, no negative. So you either have no negatives or you have no fraction. You cannot have negatives and fraction at the same time. So in this answer, if you leave it there, look, you have fractions because this is a fraction. You also have negative. You cannot have a mix of fraction and negative. So here you got to choose to get rid of that negative exponent, or you can I guess that's the only way, right? So how do we get rid of negative? You flip, but this time x to negative 6 is already in the denominator, okay, in the bottom. When you flip it, you're going to flip it to the top. You will have y4 and x to the 6. After you flip this part to the top, the bottom is gone. You have over 1, but you don't have to put over 1 there, and you can get rid of that. So the answer would be y4 x to the 6. And in this answer, there's you don't have a mix of negative and fraction. Actually, I don't have negatives or I don't have fraction. Okay, so just make sure you do one more step. For this one, you must do it. For the first one, you can stop there because I don't have fraction. I have negative, but I know fraction. Okay, any question? So I don't know if everybody understand this part of flipping here, because previously when we flipped, it was like, a to the negative n, you flip to the bottom, right? But what if you have 1 over a to negative n? When you flip it, you will get to the top because, like I said, these two, they are reciprocal each other. So if you want to flip it, if a to the negative m is already in the denominator, when you do the flip, you're going to flip it to the top. It's going to become positive, and that 1 is kind of like sorry. So this 1 stays on the top. Originally, we have 1 on the top. When you flip the bottom to the top, you get 1 times a to the n, but it's not going to change the top. So it's going to stay as a to the n. But bottom, after you flip it, you actually have invisible 1 in front of it, right? So you can put a 1 there or just omit it. Okay, so when we do flipping, if it's on the top, you flip to the bottom. If it's on the bottom, you flip to the top. So now we go back to number 3. Any question about number 2, especially about the flipping part? Okay, number 3, let me change this one to a minus and this one to a minus and that one to a minus. Okay. All right, so when we do this question, we still apply the formula. Previously, I had a 5 minus 4, right? So previously, when you did the number 3, it's 5 minus 4. So x to 5 minus 4 and y to the 4 minus 3, because 5 minus 4 would be 1 and 4 minus 3 would be 1. But now, when you subtract, it's not going to be 5, it's negative 5. So you're going to be doing negative 5 minus 4, which is negative 9. And also, we don't have 4 minus 3. We have negative 4 minus negative 3. Okay, especially this part right here. Be very careful. Because a lot of students thought, okay, when I divide them, I get negative 7. Because negative 4 minus 3 is negative 7. Be careful. The formula says you subtract the top exponent and the bottom exponent. So the top exponent is negative 4. The bottom is negative 3. There's already a minus sign there. So when you put another minus between them, it's negative 4 minus negative 3. So negative 4 minus negative 3, you got to do keep, change. That gives you a negative 1 there. So the answer will be x to negative 9, y to negative 1. Okay, so the trick is especially the second part. I get the answer of negative 7 a lot because they are thinking, some students thought, I'm doing subtraction, it's negative 4 minus 3. I am doing subtraction of exponents, but that minus sign is already in the exponent. So you need to have another minus in the formula. So the top exponent minus the bottom exponent, where the top is negative 4 and the bottom is negative 3, and that minus just comes from the formula. So that way, you will have to do keep, change to do the subtraction. Okay, any question about this one? So for the number 3, you can leave your answer this way. You don't have to flip it. If you want to flip it, you will get x to the 9, y to the first on the bottom, because both exponents are negative. If the exponent is negative, you flip to you have to do the flipping. And they're on the top, so we flip them to the bottom. But you can leave them as it is because I don't have any fractions in here. That's fine to leave the answers as negative exponents. All right. Now, the final question for 5.1, let me change. Well, all I have to do is change this to negative. Okay, I will keep the other ones as they are. So the inside will still be the same. You're doing exactly the same thing, divide. But this becomes negative. So when I raise the exponent, you're going to raise 5 to negative 2. The outside exponent is negative. So this will become negative 2. This become negative 2. So which means everything in the parentheses will be raised to negative 2, negative second. Okay, how do we do 5 to negative 2? Well, it's the same as what we did in the bonus, right? So previously we did in a bonus, it's like 2 to negative 4. We don't have any formula for this. You just go by definition. To do 5 to negative 2, it means 5 squared, which is 25. And I got to flip 25. I get 1 over 25. So instead of having 25, you're going to have the inverse. It's 1 over 25. Now, similarly here, you have 2 times negative 4 to get negative 4, and 2 times negative 2. Sorry, 2 times negative 2 get negative 4. Okay, and this answer is acceptable. You may say, well, you have a combination of negative and fraction, but the fraction is just the number as a fraction, not you don't have a negative exponent in the denominator. That would be fine. So if you want to leave the answer as 1 over 25 a fourth times b fourth, you can. Or if you want to flip it, both of them will be flipped to the bottom. So you're going to have 1 over 25 a fourth b fourth. Okay. All right, so that's these are going to be the questions you're going to do in the second exam. You will have some negative exponents in there, but the way you did will be similar to the one you did in the first exam, but just with the negative exponents. All right, questions? Okay, so we're going to move on to section 5.2, radicals. Okay, so previously we talked about negative 5.1. Let me go up there. So we had the negative exponents. We talked about exponents, integers as exponents, but mainly we're talking about negative exponents, what it means. So 5.2, we are going to talk about radicals. It seems like they have nothing to do with each other. Why do they put in, radicals like square root of 2, square root of 8? But negative exponents look like this, 2 to negative 1 or 8 to negative 3. So it doesn't look like they have anything in common. Why do they put these two different topics in the same chapter? Okay, well, the reason is radicals can also be written as exponents. So for example, 2 square root of 2, actually you could write square root of 2 as 2 to 1/2, and square root of 8 as 8 to 1/2. Or I can do a third power, maybe cube root of 4. That can be written as 4 to 1/3. So that exponent there, I'm sorry, not exponent, the square root or the third root, or you even could have like maybe fifth root of 2 to the third. This can be written as 2 to the 3/5. So this is the new thing. The exponent, look, it's not an integer anymore. We know if it's, if you get 2 to the third, it means you have this 3 means 3 copies of 2. If it's negative, if I do 2 to negative 3, it just means 3 copies of 2 and then flip. That's negative makes us do an extra operation flip. But the fraction really have, doesn't make sense at all, right? Because you couldn't do a half copy of 2. You couldn't do half copy of 8. You couldn't do a third copy of 4 or 3/5 copy of 2. Okay, so this symbol is mainly symbolic. Okay, the reason we create those symbols is, especially in calculus class, when you apply those formulas, you will need to make sure your expressions are described in this form, the exponential form, because all the formulas are written in that form, exponential form. So when you have radicals, you actually can change them to a fractional exponent. Okay, how we do it, we will talk about this later in probably next week. And so I will just kind of give you an idea why we put radicals and negative exponents in the same chapter, because technically they are the same thing. They're all exponents. Just one of them, we have a negative number as exponent. The other one, we have a fraction as exponent. Okay. All right, so now we're going to look at how to simplify radicals. And we start with, so where do radicals come from? In the history of mathematics, or why do we call them radicals? Radical English meaning means the same as irrational. So we also call radical numbers irrational numbers. Well, we know rational means, irrational means not rational. So it's kind of like, why do we call those numbers not rational? Because back in a few hundred BC, 400, 500 BC, maybe 300 BC, the Pythagoreans, they did not know radical numbers. The only numbers they knew were fractions, and they already knew fractions at that time. And so they had a lot of students. They created schools. They had students. They actually published a lot of math books, and a lot of them, most of the books, when they were talking about the theorems, the properties, they're based on fractions. They didn't know there were, radical numbers at that time. And later, they did find the radical numbers. Well, one common example is if you have a square and with the side 1, 1, 1, 1, and when you draw the diagonal, we know by Pythagorean theorem, this side should be, 1 squared plus 1 squared, which is equal to 2, and take a square root. So that diagonal actually is square root of 2. And where the interesting is, the difficult thing for them to understand at that time was square root of 2 is not a fraction. Because most of the number, they were thinking any number can be described as a fraction, but square root of 2 is not a fraction. You cannot write square root of 2 as like something over something. This can be proved in high-level math. Actually, I'm teaching a high-level math, which is called discrete mathematics, and the students will learn how to prove square root 2 is you cannot write square root 2 as a fraction. But for this class, you don't need to know that, know the proof. You will just know, okay, square root 2 is not a fraction. So that's why they called it irrational, or they called it radical. And there was a story that when some of them found out about radical numbers, square root 2, such as because they were afraid, they would question their reputation or all their books they wrote, and so they swore nobody would disclose anything about radical numbers. And they actually, there was a story, they drowned one of the students who tried to disclose radical numbers. So that was the story why we call these numbers radical, because it was very difficult for them to understand how could we have a number that is not a fraction at that time. Okay, but now we understand we could have numbers that are not fractions. Okay, so the topic here in 5.2 is to learn to simplify radical. When we have a radical number, we simplify it. So this symbol created, this symbol is sort of try to imitate this kind of, I guess, first letter R, sort of, not exactly, but kind of like that. So this symbol represents radical. Now, to talk about radical, how to simplify it, I want to start with the exponents, because radicals are sort of like the inverse of exponents. So for example, we did questions like, oops, okay. So we did exponents. For example, 2 to the third is equal to, means 2 times 2 times 2, which is equal to 8. So what if we want to do the other type of question? So I want to ask you to find out what number to a third is equal to 8. So instead of, look at these two questions. So the question we did before, the exponents, we give you 2 to a third. We ask you this is equal to what? But now we tell you the answer 8, but we want to find out what number to the third will be equal to 8. So the sort of like the inverse type of question. So we're looking for this number 2 here. Okay, so parent, if you're familiar with the cube numbers, we know the answer should be 2 here. So when we multiply 3 copies of 2, we will get 8. But of course, we don't want to write our question in this way, to always put a parenthesis and third power equals 8. So instead, we created that symbol. So if you are looking for one number to the third is equal to 8, we call this number radical. We create the symbol. Like I said, it's sort of similar to the first letter of radical, the word radical, R. And this exponent will become the radical index. We put it right here to indicate this is the third root. We don't call it exponent anymore. We call it the third root. And this number 8, we're going to put right under the radical sign. So within the radical sign. So when you look at this cube root of 8, what does it ask for? It's the same question as this one right here. It's asking you what number, when you multiply 3 copies of one number is 8. The first intuitive solution will be, okay, so it's like whenever you see this, it's asking you what number, how can I write 8 as 3 copies of something? Okay, so because it's like asking you 3 copies of one number is 8, right? 3 copies of, or you can say multiply 3 copies of which number? You're going to get 8. So I can rewrite 8, break down 8 as 2 times 2 times 2. Then I can see, okay, well, 8 apparently is multiplying 3 copies of 2. So that tells me the answer is 2. Okay, so it's the same as what you're gonna get. If I ask you to fill in the blank, you will put down 2 here, right? So that's the answer you're gonna get for that. Okay, so this symbol we created is to tell you to find the base, what's gonna be the base, and this tells you how many copies it's gonna do. So how many copies of 3 copies of one number is going to be 8? Well, you find out it's 2, 2, 2. So the answer will be 2. So it's sort of like the first solution you're going to do is to break down 8, to factor 8 as the product of all the prime numbers, and you look for, if the index is 3, you look for 3 copies of something. If you can find 3 copies of anything, that would be the answer. So as you can see, it's 3 copies of 2. And when you take them out, you're not going to get 8 anymore. Remember, we only need the base because this 3 is already there. So you're just going to write down 1 copy of 2. You're not going to write down 3 copies of 2. So when you have 3 copies of 2 and take them out, you're going to get 1 copy. When you take 3 copies of 2 out of the third root, you can get a single copy. Okay. All right. So that's the way we're going to do it. Some of the students may say, well, I can see the answer is 2. You don't have to show the work. But later, some of the numbers, they're not exactly perfect cube. You may have to do this process. Okay. By the way, square root, the index can be, so for example, I want to do square root of 4. And the little index can be omitted, so you can just write this down. Because square root is the most common radical number we use. So we write this very often, so we just omit that 2 there. If I don't have anything, it means that you are doing 2 copies. You're looking for the square root. Okay, so everyone knows the answer is 2, right? But if I want to solve it by factoring, this is like asking you which number squared is 4. So of course we know 2 squared is 4. So we have 2 copies of 2. So when you bring 2 copies of 2 out of the square root, you're going to get a single copy of 2. So let me put those 2 examples together. Cube root of 8, so we got 2, 2, 2. That's going to be 2. So when you simplify a square root number, you try to look for 2 copies of something. And when you try to simplify cube root, you look for 3 copies of something. And of anything, you get that out to get a single copy. Okay. All right. So now we're going to simplify. Let's see. What if it's not a perfect? What if it's not a perfect square or perfect cube? So the first homework question, this is the one they ask you to do, cube root. So it's like asking you, negative 125, how do you write negative 125 as a product of 3 copies of something? Okay, so whatever you get will be the answer. Okay, so I can do a similar one. So I did a cube root of 8. What if I want to do cube root of negative 8? So when I do this, I want to rewrite negative 8 as something times something times something. It's the same number. So I'll try to see if I can do that. And I realized that I could do negative 2 times negative 2 times negative 2, because negative times negative is positive, and times another negative would be negative. So apparently negative 8 is exactly 3 copies of negative 2. So the answer will be negative 2. Okay, but if you want to skip this step, just write down the answer negative 2. That's fine, because this question is the same as asking you to do this. Okay, 1 number to the third is negative 8. Well, apparently it's negative 2. Okay, because negative 2 times negative 2 times negative 2 is negative 8. All right, so this is an example similar to your homework question. The second one will be a square root question, but this number given will not be, okay, the homework is square root 160. I can do maybe 180. Okay, now notice there's no index here, which means square root means little index 2. So it's kind of like asking you, can you write 180 as something times something? Well, not all of numbers are perfect square root. So we are going to use the same idea. We're gonna, when we simplify it, we try to take out perfect squares. So if you can see which perfect square 180 contains, that would be great. But if you say I can't see it, then you're gonna have to. So 180, we did this during the first week of the review, in review class. So we break down as 2 times 90, and 90 would be 9 times 10, and 9 is 3 times 3, and 10 is 2 times 5. So 180 actually can be factored as, I'm gonna circle the prime numbers we have. I'm gonna try to put them in the order. So 2 times 2 times 3 times 3 times 5. Okay, after I factor 180. And what we're going to do is we're going to look for perfect squares. Because again, whenever you do square root, it's like asking you, wait, did I have square root? I don't have that. Okay, so whenever you do square root, it's like asking one number squared is 4. So we're trying to look for 2 copies of anything. So right here, I see 2 copies of 2. I see 2 copies of 3. So these ones can be simplified. Technically, we're doing this. We're going to split them into, but this step can be omitted. You don't really have to do that. So as you can see, got 2 copies of 2. That can be taken out to get a 2. 2 copies of 3, that can be taken out to get a 3. And that 5 there, you don't have 2 copies of anything, so that will have to stay in the radical. So you're going to multiply 2 and 3 to get 6 and square root of 5. So that's the final answer. Okay, but a lot of steps here can be omitted. You could show this step and then just that step, because when you take, well, maybe you can do one more step like this, but that step can be omitted and you can skip that. Okay, so when you see 2 copies of 2, you take them out, you get a 2. 2 copies of 3 taken out, you get 3. 5, it's a single copy, it has to stay. So you get 2 times 3, 6 square root of 5. Okay. All right. So that is how we simplify radical, square root of 180. Any question? I'm not going to go ahead and do 3, 4, 5, 6 examples similar to the last one in this section in 5.2. Because the other 3 all have fractions. So I'm going to do that later. This one is a little similar to, so previously I did a cube root. We're looking for 3 copies. So maybe I can do, how about we do square root of 360 maybe. Okay. So when you have the index 3, that means you're looking for 3 copies of anything, just like the one we did. Cube root of 8. The answer is 2 because 8 is 3 copies of 2. It's like doing one number to the third is 8, or 3 copies of one number is 8. So when we do this question, unfortunately 360 is not exactly 3 copies of anything. So what we can do is we can still factor to take out 3 copies of something. So 360, when we factor, maybe I can just add, well, okay, I'm going to go ahead and add 1 here. So 360 is 2 times 180, and 180 we can continue to break down like that. So we are going to have an extra 2 there. So we have 2, 2, 2, and 3 2s and 2 3s and a 5. So after I factor 360, we get 2 times 2 times 2 and times 3 times 3 times 5. So again, remember, third root with a cube root means you are going to find out that. So again, this step can be omitted. I'm going to write it down to explain to you. So you can get cube root of these two radicals. And notice that 3 copies of 2 can be simplified to get a 2. It's like cube root of 8. The other ones, I cannot simplify it any further because there are no 3 copies of anything. So I just have to multiply them 3 times 3 is 9. 9 times 5 is 45. So we get the answer 2 times cube root of 45. The times multiplication can be omitted. You can just say 2 cube root of 45. So that would be the final answer. Okay, so notice that cube root, you must have 3 copies in order to simplify it. Even if you have 2 copies, like right here, you got 2 copies of 3, you cannot get them out. But if you have 3 copies of anything, you can't get them out. Okay, now let's look at what if we have fractions like the second, the third one, 3, 4, 5. I think I can go, well, okay, so let's do a similar example here. Maybe we can put, let's do 9 on the bottom and 8, 20, 20. So square root of 20 over 9. Okay, so when we have a fraction under this radical, we can also split as square root of 20 over square root of 9. And that's going to give us square root of 9, it's a perfect square. So we can get 3 immediately. Square root of 9 is equal to 3. Or because 9 is 2 copies of 3. But square root of 20, it's not a perfect square. So we can break down as 2 times 2 times 5. And there are 2 copies of 2. That can be taken out. So that gives us a single copy of 2. And 5, because it's single copy, inside the radical sign. Remember, we need 2 copies to take it out. So we can't take 5 out. Just leave it there. And the bottom 3, we keep it. So that would be the final answer. Okay, so what we're trying to do is we try to simplify the numbers within the radical sign as much as possible. So you're going to have to take all the 2 copies out if you have any. Now, the next example. But sometimes, what if we have a radical in the denominator? In this case, luckily, 9 is a perfect square. After I take square root of 9, I just end up with a 3. It's a perfect square. But what if it's not a perfect square? Like in the next example, I'm just going to put square root of 3 here, and the 2 square root of I can do maybe 18. Well, I'm sorry. Maybe I can do. Okay. So in this case, square root of 3, you cannot get 3 out because 3 is a single copy. Let me go ahead and work on, let's see, 2 square root of 18 and square root of 3. Square root of 18 actually can be simplified further because 18, if you look at the square root of 18, you have 2 times 3 times 3 as we have 2 copies of 3. So that can be taken out to get a 3. Square root, single number 2 stays within the radical sign. So the top actually can be simplified, the square root of 18, but square root of 3, you can't simplify it. Okay, so maybe for this question, there are two ways you could do, but I guess I can go ahead and do that. Simplify the square root of 18. I will get, I'm going to go ahead and copy the answer here, 3 square root of 2 over square root of 3. So that gives me negative, that is 2 times 3 is 6, square root of 2 over square root of 3. Okay. By the way, you won't be able to multiply the 6 and 2 there. And notice 6 is outside the radical, but 2 is within the radical. You can't multiply the numbers outside and inside the radical. Okay, but is this answer accepted? Well, unfortunately, it's not, because there is a rule. I will write down the rule in a second for you. How do we know whether this is simplified for when you have a radical number? So whenever we have fractions, no radical is allowed in the denominator. So no radicals in the denominator. It's just a rule we give whenever we have fractions and radicals. So this is not allowed. Square root of 3. In the denominator, you can have, see, like this one is allowed because square root of 5 is in the denominator. And in the numerator, I'm sorry, numerator, you can have radicals, but the denominator, you cannot have radicals. Previously, 3 is not a radical, so that's fine. Okay, but in this case, square root 3 is a radical. We cannot have that. So what can we do to get rid of this radical sign? So the idea comes from a property of fractions. So if you remember when we have fractions, when we try to add, if I ask you to add 3/4 plus maybe 1/6, what we did before was we can find the common denominator 12, and we can multiply both top and bottom by 3, and this one both top and bottom by 2. And that way we get 9/12 plus 2/12. We can add the numerators because they have a common denominator. So the idea right here will be applied similarly to get rid of the radical in the denominator. So notice that if you are given a fraction 3/4, you can multiply both top and bottom by the same number without changing the fraction. Although you get 9/12, looks like a different fraction, but these two fractions are equivalent. 3/4 is equivalent to 9/12. After you double, you triple both the denominator and numerator. Okay, so they're still equivalent. They just look different, but they're equivalent. If you divide them to change them to decimal, you'll find out they're both equal to 0.75 and 0.75. So they are, although these two fractions look different, they are actually equal. So the same idea can be applied here. I mean, previously we didn't have to deal with radicals. It's all whole numbers. So we multiply both top and bottom by 3. It's a whole number. Well, you can actually multiply both top and bottom by square root of 3. So if you want, you can multiply square root 3, square root 3. You're going to get 3 square root 3 and 4 square root 3. They're still going to be, equivalent. So that's what we're going to do. In order to get rid of the radical sign, I can multiply both top and bottom by square root 3. And this is the same process as we did, equaling denominator. But how did I know I should multiply by square root 3? When we equal the denominators, we have to get 12. So we know we should multiply by 3. But why did we multiply square root 3 here? Because we know that when you have a square root 3, and you must have 2 copies in order to get rid of the radical sign. Remember, square root of 4 is equal to 2. Square root of 9 is equal to 3. Why? Because 4 is a perfect square, 9 is a perfect square. Or in other words, 4 is actually exactly 2 copies of 2, and 9 is exactly 2 copies of 3. So if you have a single copy 3, you can't get rid of the radical sign. But if you have 2 copies of anything, look, the answer is just a whole number now. You don't have any radical sign. So that gives me an idea. I should multiply another copy of square root 3. And square root 3 times square root 3, that gives me of square root of 3 times 3, which is square root of 9. And that gives me a perfect square. And if I simplify that further, that is just going to be 3. When we have 2 copies of 3, you can take them out to get a single copy of 3. The good thing is the radical sign is gone. Okay, so that's all we care. On the top, the minus sign will still be here. The top 6 will stay. Square root of 2 times square root of 3. You can multiply 2 and 3 together. That gives us -6 square root of 6. Okay, so the important step is right here. How do we get rid of this radical sign in the denominator? You can multiply another copy of itself. And in that case, you get 2 copies of 3 under the radical sign, and that can be simplified as a whole number 3. The top, you may still have radicals because 2 times 3, both of them are single copies, and you're just going to have to keep them with the within the radical sign to get square root of 6 there. Okay, and notice although this fraction contains radicals, it's still a fraction. If you have a fraction, we must remember to reduce the fraction. And notice we have right here 3 and 6, they can be reduced. Okay, because it's multiplication, so you're going to be able to 3 goes into 6 2 times. So the answer will be -2 square root of 6. Okay, so in this case, I actually got rid of the denominator. In your homework, I don't think you can. You will still have a square root. You will still have a like 5, something over 5 there. Okay. All right. So this is how we do this question. The rule is, why do we have to do this step right here from here to here? Because we are not allowed to have radicals in the denominator. Okay. Questions? Okay, so one more example for the last example for section 5.2. It's kind of similar to this. It's just gonna, it's just an extra example here. So negative 3 square root of, I can put the square root of 7 here, over square root of, maybe I can do 50. Okay. So as we mentioned previously, we are not allowed to have a radical in the denominator. Okay, so the two ways you can do. First, you may say, okay, can I multiply another copy of square root of 50? Yes, you can. But I would go ahead and simplify the radical first. And because 50 apparently it contains 25, which is a perfect square. So whenever we have a radical, we must get all the perfect squares out. So 2050 can be factored as 2 times 5 times 5. And 5 times 5, that's a perfect square. So that can be taken out the square root. That gives us a 5. But that 2 is a single 2, single copy 2 that stays within the radical sign. And the top still I copy it. Okay. And notice that originally I have a very big number 50 within the radical sign, but now I just have a 2. So which makes the next part much easier. Instead of multiplying another copy of square root 50, I can multiply another copy of square root 2. So times it by square root 2 and times by square root 2. Okay, again, why do I do that? Because we're not allowed to have a radical square root 2 in the denominator. But what about this 5? 5 is not a radical. It's a whole number, so we don't have to worry about a 5. It can just stay in the denominator. But in order to get rid of square root 2, similar to the way we got rid of square root 3, we multiply another copy. So I multiply another copy of square root 2. And notice square root 2 times square root 2 will give you square root of 4, which can be simplified to a 2. So the denominator, I skip a step here. I just give you 5 times 2. 5 comes the original 5, and these two, if you multiply them, you're going to get square root of 4. And square root of 4 is equal to 2. Okay, so no radicals anymore. In the numerator, negative 3 is outside the radical. It stays. And square root of 7 times square root of 2, we can multiply both numbers within the radical signs. So 2 times 7 is 14. Okay, and notice 2 and 7, they are both prime. You cannot break them down any further. And you can't find any more 2 copies. So square root of 14 has to stay there. The bottom, I can go ahead and multiply them out to get 10 in the denominator. Negative, I can move it down, put it in front of the whole fraction. So the final answer would be negative 3 square root of 14 over 10. Okay. All right. Questions? Okay. I'm trying to see. We have about, okay. I don't know. I'm trying to think if I should give you some practice problems before we move on to the next section. Okay, so maybe let me give you a quick link here so you will. So before we move on, I want to make sure you understand how to do this. So let's do a two quick problems here. Again, for the radical, how do you write it? You can just write SQ square root, SQRT. You can put it that way. SQRT, square root of the first question. So you can click on that link and put your answer there. The first question is square root of 27. The second question, because it has fractions, I'm going to write it here so you can probably see better. Let's do square root of okay. You can put probably 2.
For number 2, the link says radical 5 instead of radical 7.
Oh.
By yours.
Oh, sorry. Let me change it to 7. Okay. Thanks. Do you have trouble doing these questions? Let me know if you have trouble. Okay, I still don't see any submissions yet.
I submitted mine. It might be coming through.
Oh,
I've
okay.
also already submitted mine.
Okay, that's weird. Okay, let me refresh. Oh, okay. Well, usually it automatically refreshes, but this time it didn't. So I actually see 7 responses already. Okay. Okay. All right. Looks like the first one, everybody got it right. All 7 responses. Jackson, Ellie, Jenna, Garrett, Ray, Abby, and Colin. But the second one looks like some of the students, let's see. Oh, okay. Actually, most of you got the second one right. Okay. Also, that's good. Let me go over these two. So the first one, I don't know how you guys did it, but the 2 ways. One way is to break all the way down and find 2 copies and take that out to get a 3. That's what I showed you. There is a quick way. If you say I can see 9 is a perfect square, which is a factor of 27. So the other way to do it, you could just write it as 9 times 3 instead of 3 times 3 times 3, because square root of 9 is 3. So that square root of 9, you can get a 3. The other single 3 will stay within the radical sign. So that's another way, maybe a little quicker in writing. Okay, the second one, and most of you again got it right. So in order to get rid of the radical 7, because that's not allowed, so we're going to multiply another copy of it. I think, Abby, you made a mistake. I don't know what you did. The bottom is right, which is 7, because square root of 7 times square root of 7, you're going to get 2 copies of 7, which can come out of the radical sign to become a 7. Or it's square root of 49, that's 7. But the top, when we multiply, this 2 will stay because it's outside the radical. These two, they're both numbers, 3 and 7, they are both within the radical sign. You can multiply them to get 3 times 7, which is 21. And that would be the final answer. Okay, 2 and 7, they don't have, 2 and 7 are both out of radical sign, and they don't have anything in common. So we'll just leave them as, and this it is. Okay, so that looks like most of you got the idea how to do this. So we can move on to variables. Okay, I think I may have to cross out some questions in section 5.3. I don't want to rush to finish everything, and I want to make sure everybody understands the concept. So I may cross out the first 2 problems. So I'll let you know at the end of the class. So I'm going to go ahead and skip the first 2 examples in section 5.3. Because section 5.3 has 2 topics. One of them is like the first 2, to combine radicals. But I think I may talk about these next week. So that was the first 2. In the homework, it's number 16 and number 17. And the other type is simplify the radicals. Radicals, just like what we just did. Radicals containing variables. Okay, so previously all the examples that I gave you plus these 2 questions, we didn't have any variables, it's just numbers. But what if we put an x squared or y third in there? What would we do? So the idea is very similar. You will try to, if you have a square root of anything, I guess the one we did, square root 27, I can put, x squared y to the third there. And if you have square root, you try to take out 2 copies of something. If you have cube root, if it's cube root, you will try to take 3 copies of something out, including the variables. So if, for example, right here, the first case, square root, and we try to, you can split into 3 questions, or you could do them together. So 27 will still be 3. I can do 9 times 3 because 9 is a perfect square. Or you can break it all the way down to 3 times 3 times 3. And x squared, now I'm going to break it down as x times x, factor it as x times x, y third, y times y times y. So the idea is very similar. Maybe I should go ahead and just put 3 times 3 here to be consistent. Okay, so whenever we simplify radical square root of anything, we try to find 2 copies to take it out. So like these two, and these two. So I can not factor, I can pull them out of the radical sign, because the square root of 9, or square root of 3 times 3 is just going to be a 3. And when I have 2 copies of x, that can come out similar to that. You get a single copy of x. And when you get 2 copies of y, that can come out. You can get a single copy of y. That's exactly the same idea. Whenever we have 2 copies of anything, it comes out of the radical, becomes a single copy. But this 3 and that y, we don't have 2 copies of another 2 copies of 3 or another 2 copies of y. They will just stay within the radical sign. Okay, and the multiplication sign can be omitted. So you can just put 3 all closer together, 3xy, square root of 3y. So actually there's multiplication everywhere, but you can omit all of the dots. So that idea is very similar. Okay, but if you have cube root, you're going to have to look for 3 copies. So let's try to do this again. So the factoring part is exactly the same. I factor 27 as 333, x squared as xx, y third as y. This time you're looking for 3 copies. So we have 3 copies of 3 and 3 copies of y. Okay, these can come out, but 2 copies are not enough. So we're going to take these out to get a single copy, and these 3 copies of y out to get a single copy, and cube root of x times x will be x squared. Okay, so don't forget to, I noticed in the writing, a lot of students forgot to write down the third root there. Don't forget, only square root, that little 2 can be omitted. If it's third root, fourth root, fifth root, you cannot omit that. You must write that little 3 there. Okay, and try to stay, keep a little distance here. Otherwise, if you put them too closer, we might think, it's y to the third x squared. Okay, so make sure you leave a little space here so we know this is the cube root of x squared, not y to the third. Okay, all right, so now what if I have a very big, in this example, the exponents I gave you are very small, 2, 3, 2, 3. So I could expand it as xx, y. But what if I have x to the 20, y to the 30? If I do this way, that's going to be very time consuming. So let's try to look at this again. So by the way, the numbers, you're going to do it the same way as we did discussed before, how you simplify it. It's just the variables. So what if I have x to 20th, y to the maybe 25th? So we certainly don't want to write down x to 20 as x as 20 copies of x and 25 copies of y. But if you get the idea of what we were just doing, see, we are looking for 2 copies of x. Or it's like asking you, when you have 2 copies of x, it's like how many, it's like a pair, whenever a group of 2, a group of 2 x's, or we can call it a pair of x's. So anytime you have a pair of 3, you can come out to get you a single 3. If you're a pair of x, you get a x. If you have a pair of y, you get a y, right? So if you have more pairs, it just gives you more. Okay, maybe I should do maybe a small one before I do 20th. So let's try to do, how about I try to do x to the 5th and y to the 6th. And you can look at the process. So again, 27 is 3 times 3 times 3. X will 5 copies. 1, 2, 3, 4, 5. Y is 6 copies. 1, 2, 3, 4, 5, 6. So we're looking for a pattern here. So we don't have to expand every single time. So we have a pair of 3. So I get a 3 out. I have a pair of x. So that gives me an x. Another pair of x. That gives me x. No more pairs. One pair of y. One pair of y. One pair of y. So that's all the ones pairs I could find. And the ones left will be this 3 and this x. So they stay within the radical sign, 3x. Okay, let me put them closer. So you're going to get x3, x squared, y to the 3rd, and square root of 3x. So that would be the simplified form. But let's find a pattern so we don't have to expand it every single time. So look, squared, 3rd. It's like asking you, we have 5 copies of x. How many pairs can you get at most? So think that if you have 5 students, I want you guys to form groups of 2 to work on a project. You can get at most two groups, right? So it's like 5 divided by 2. You get two groups of 2 pairs, 2 groups of 2. But you're going to have one student left, and that student X will stay in there, okay? And similarly, if you have 6 copies of Y, I want 6 Y's to make groups of 2. So that's going to give you exactly 3 groups, because every 2 make a pair, a group. These 2 make a group. These 2 make a group. So you will have 3 groups of Y. So Y to the 3rd, and no more Y left. Okay, so the pattern, we found the pattern. The tip is you're going to find out 5 contains how many pairs at most, and what's the leftover? How many left will stay within the radical sign? How many pairs will become the exponent of that x? Okay, so now we can do the question we just had at the beginning. What if I have x to the 20th and y to 25th? So again, for a number, you have to do the same way as we did it before. There's no quick way. There's no pattern. So you would just have to get 3 out, one single 3 out, and there's another 3 left within the radical sign. Now, what about x to 20th? Out of the square root, what will the exponent be? X to what? Anybody following the pattern? You look for 2, how many pairs? Yes, go ahead.
X to the 10th.
X to the 10th, right? Thank you, Ray. That's right. So you're just gonna do, when you have 20 copies of X, you try to find how many pairs. 20 divided by 2, you can get exactly 10 pairs or 10 groups of 2. No more X left, so you don't put any X here. But 25 copies of Y, that's gonna give you how many pairs of Y?
12.
12. Good, thanks, Bryson. Okay, and there's going to be 1 left. Okay, maybe I should move this closer. Okay, the 12 should closer to Y, and there's 1 left over. Okay, so what you can do is 25 divided by 2. That gives you 14, and there's 1 left over, 1 Y left over. Okay, so that would be the final answer. Okay, so with the variables, actually, they're easier than the numbers. With numbers, there's no quick way. You just have to break it down. Like the example I did before with the square root 180, I have to break all the way down to so I can see. Unless you can see, say I can see 180 contains 36. I mean, if you can see that, say 180 is 36 times 5, that's great. But most students probably cannot see that. 180 is 36 times 5, and square root of 36 is 6, and square root of 5 will still be square root of 5. So with numbers, especially big numbers, really there's no quick way. You have to break it down to look for 2 copies. But with variables, actually much easier. You see, because you see how many and how many copies of X you have, how many copies of Y you have. When you have 180, you don't see how many copies of 2, how many copies of 3. You have to break it down to see that, right? Okay, so now similarly, if you have the third root, what if the same question, if I want you to do the cube root? Okay, so you're looking for, okay, so can do the same thing here, cube root, but we change it to cube root of 27, X to the 20th, Y to 25th. So remember this time we need 3 copies to get them out of the cube root. So first of all, cube root 27 is going to be 3. Well, what about X to the 20th? So you are going to find out a group of 20 copies of X, 20 students divided into groups of 3. So how many groups can I get at the most? You can take 20 divided by 3. 6, yes, thanks, Bryson. And you're going to have 2 left over, okay? So we are going to have 6 groups of 3, and you're going to have X squared, 2 left, okay? Because 3 times 6 is 18 plus 2. And Y to 25, similarly, 25 divided by 3, you can get, so imagine you have 25 students divided into groups of 3, you can get 8 groups with 1 left over, 1 student left over. So you will have a Y to the 8th and Y to the 1st as a leftover. Okay, so it's like dividing 20 divided by 3, you get 6 groups, okay, or 6 triples. And 25 divided by 3, you get 8 triples, but you will have 2 left over of X and 1 Y left. Okay, all right, so with these, you should be able to do the last, so not last, 25, 27. So these examples will help you do homework 25, 27, and 50, and 54. Number 54, okay. Let's see. So the last 2 questions are also similar to the one I just asked you to simplify before, like the one with the radical in the denominator, but we have variables in there. So let's look at examples similar to that. Let's see, square root of, we can do something similar. So the one I asked you to do without variables. So what if I have maybe 5a over 3b? Okay, so first of all, we can still split into 2 problems, square root of 3a. So you can, so that's the top, that's bottom. When you take the square root of fraction, you can take the square root of the top and take square root of the bottom. So you get square root of 5a divided by square root of 3b. And next, again, no radicals allowed. So this is not allowed. No radicals allowed in the denominator. So we need to get rid of it. So do you remember that what we did in that question that I gave you? I gave you square root of 7. In order to get rid of square root of 7, I multiply another copy of itself. So I can get 2 copies of 7. That will become a 7. And similarly, when I had a square root of 3, I just multiply another copy of square root of 3. So the same thing here. If you want to get rid of square root of 3b, okay, that's a b here, sorry. So this is 3b. That means we need to multiply another copy of itself, which includes 3 and a b. So another copy of itself. The idea is the same as we did before. Just we have variables. Okay, so if it's square root of 3, you multiply square root of 3 because you can get 3. But now you have a square root of 3b. If you multiply square root of 3b, that's going to give you, look, if I put them together to show you 3b and 3b, we got 2 copies of 3 and 2 copies of b. That's going to give you 3b. Radical's going to disappear. Okay, so the bottom, after we multiply them, we should just get a 3b. No radicals. That's what we wanted in the simplified form. The top, we multiply them out the same way. So we're going to do 5a times 3b. Maybe I should not skip this step. When you do the homework, you can skip the step. Skip this step right here. But so you may skip this. I'm going to show you how I got that. So this is how I multiply 3b and 3b, because 2 copies of 3, that gives me a 3. 2 copies of b, that gives me a b. Nothing left under the radical sign. So the radical sign would disappear. But in the denominator, 3 times 5 is 15. A times b would just be ab, all of them. So that would be the final answer. Square root of 15ab over 3b. Okay. So the final example for today is going to be, let's see, do a similar question to x3rd. Okay, so square root of 3a divided by square root of, I did 50 before. I'm going to use that number and just put b to the 5th. Okay, so the first thing I would like to do is to, instead of trying to say get rid of the radical in the denominator, I'm going to try to simplify this first. So there is a radical in the denominator, but it's usually, it will make it your process easier later. So first of all, I'm going to try to simplify this radical. So 50 is 25. Let's just go ahead and write down 5 times 5. So it's 5 times 5 times 2. B fifth, you can leave it as it is, because we can simplify that by dividing to see how many groups of 2, how many pairs of B we can get. So 2 copies of 5, they can come out to get a 5. B to the 5th, that's exactly b squared. 5 b's can be divided into 2 pairs at most with 1 left over. So we're going to have a 2 left and a 1b left. Okay, so I'm going to go ahead. Usually that's probably the quickest way to do. Instead of say, okay, I can go ahead and just multiply square root 50b fifth. If you do that, you get really big numbers. I don't recommend that way. That still works. It just makes your calculation later harder. So after you simplify, notice that. See, I don't need to multiply square root 50b fifth. I just need to multiply square root 2b, another copy of the radical. I don't need to multiply 5b squared. That's because that's not within the radical. This will make your simplification process later much quicker. So let's see. The bottom 5b squared and square root 2b times square root 2b. That's just going to be 2b. Again, this can be, we can move a little faster now because 2 copies of 2 and 2 copies of b, they can come out to become 2b. And the numerator, we can just multiply the number and number. 2 times 3 is 6. A times b is ab. So again, I skipped a step here to of putting both of them under the radical. I just went ahead and multiplied them. And the bottom, notice we have 5 times 2, which is 10. B squared times b, it's b third. So if there's anything you can multiply, we should go ahead and multiply them to get the simplest form. Okay, and so that's the final answer. Okay. All right, so this process is also similar to what we did before. If you have a variable, just multiply another copy, including the variable. If you want to get anything out of the square root, you need 2 copies or a pairs of something, and just see how many pairs you have. Okay, so I think I can go ahead and tell you that to cross out in the homework, you can cross out number 16 and number 17. So cross them out under section 5.3. I will put an updated version there so to get rid of those 2 problems, and I'll put them next week. So I will talk about those next week. Okay, so I think it's, yeah. All right. Let me give you, I don't know, any questions before you do the bonus? Okay, so let me give you the bonus for today. And this is bonus number, is that 14? Yes, number 14. Okay. So the first one will be 1, how about we do cube root of 16 A 6 B 13. The second one, we can do a one with the fractions. Okay, so type present for today's class, and you can submit this later. And if you don't have questions, you can leave the meeting. If you have questions, stay in the meeting. Ray, do you have a question?